example 2. This is under principle of moment. This is under principle of moment. Let's go straight to the question because I have explained principle of moment in my first video. So a uniform wooden rod AB 120 cm long and weighing 120 Newton rests on a two sharp edge supports C and D placed 10 cm from each end of the rod respectively. A 20 weight hangs from a loop of a thread 30 cm from A, and a 90 weight hangs similarly 40 cm from B. Find the reactions at the support. So to solve this, you have to transform this into diagram. Let's go now. Solution. So now, this represents our wooden rod AB. According to the question, the length of it is 120 centimeter, or you can put it 1.2 meters. Then the weight of it is what? 120 Newton. Then according to the center of gravity, CG, the center of gravity of a uniform rod is at the midpoint. So let's see, and that is where the weight will lie. This is the weight of the rod will lie at this point. This is the weight of the rod, which is 120 Newton. So this is the, from here to here now will be 60 cm. From here to here, 60 cm. So there are two supports, C and D, placed 10 cm from each end. So from here to here, let's call this support, sharp edge C. Here is 10 centimeter. From here to here, let's call this one another sharp support D. Here is 10 centimeter. Now the next thing now is to locate this weight hang from a loop of a thread 30 cm from A. So 30 cm from here to here. So let us say here now is where they suspended. From here to here is 30 centimeter. And from here to, if we have removed 10, so from here to here will now be what? We have removed 10 now, 20 centimeter. So this is where this 20 Newton hangs. Then another one, similarly, 40 cm, we have this 90 Newton is hang what? 40 cm from B. So this is B. Move from 40. Let's move, assume that here to here is 40. Another weight of 40, 90 Newton. This is from here to here is what now? 40 centimeter. So from here to here will be what now? 30 centimeter. So we can change all these things to meter, right? Okay. So now, having put the reactions, there will be a reaction here. Let's call this reaction, let's call it X, and let's call this reaction here Y. So this reaction, they are as a result of these two supports. When you rest something, now there will be reaction in this. So this is the diagram of the what now question. So the next thing we need to do now is to find the value of this reaction. These are forces. We call this reaction forces. Then we have, for us to find these forces now, we know that for a body to be in equilibrium, upward forces, some of the upward forces must be equal to some of the downward forces. So applying this now, what are the upward forces, X and Y? So upward forces must be equals to, that is x plus y must be equals to all the forces down, 20 plus 120 plus 90. So if you do it, x plus y equals to 230. If you add up these 230, so these upward forces, sum of the upward forces equals to sum of, these are the upward forces, these are the downward forces, for this body to be in equilibrium. Then if I call this equation 1, I need to, if I want to find y first, I have to make x the subject of the formula. So x is equals to 230 minus what? Y. Call this one equation 1. So I have gotten my, so for me now to find y, if we are looking for y, if we get y now, we can now find x. You now take moment about the point C. So for us to find this y, for us to obtain this y, we have to take moment about this point. You know that moment is what? Force times perpendicular distance. So let us take moment about this. If you are taking moment about this, you now say, and this will be now from this force, take them to this point C. So we call this one clockwise moment, clockwise moment. Then we will now call this one to this. We call this one anti-clockwise. So the force times the perpendicular distance to reach here, anti-clockwise moment. So here is anti-clockwise. This is what I mean by moment. So anti-clockwise moment. So what is my clockwise? Sum of my clockwise moment, sum of clockwise moment about point C. Sum of clockwise moment about points. Let's take now this force, the distance from here to here is what? 20. So I can call here 0.2 meter. So the force now I have 20 times the perpendicular distance, which is 0.2, plus this is what now? 120. What is the perpendicular distance from here to here? If from here to here is 6 and we have removed 10, so from here to here will give me 50 cm, which is equivalent to 0.5. So I will now have 120, this force times the perpendicular distance, times 0.5 times 0. This is 0.5. Don't mind this, my board. 0.5 plus, look at this another force here. What is the distance from here to here? We have 490 times. So from here to here, if we have removed from here to here 40, and we have removed from here to here 10, 10 plus 40 is 50. So we have removed 50 from this, what now? Wooden rod, which is 120. So 120 minus 50 will give you 70. So from here to here will give us 70 cm, which is equals to 0.7. So here is times 0.7. That is the perpendicular distance. This force times the perpendicular distance. So we will now have 20 times this is 4, plus this times this is 60, plus this times this is 63. Add all of them, you have 127. So that is our what now? This is our what? Our clockwise moment. Then anti-clockwise moment about the same point. Anti-clockwise moment about the same point equals to 9. Look at only one force we have here, which is only this. So it will be y times, from here to here should be what? Now we have removed 10. So from that point to this will be what? 100 cm, which is equals to 1 meter. So from here to here is 100, which is so times y, which will give you y. So according to principle of moment, clockwise moment equals to anti-clockwise moment. So according to principle of moment now, we will now have what now? Clockwise moment equals to anti-clockwise moment. That is y equals to 127 Newton. If you equate, this is y, and clockwise moment equals to anti-clockwise. So y will be equals to what? 127 Newton. That is the principle of moment. Sum of clockwise moment equals to anti-clockwise moment. So if this is sum of the clockwise moment, this is sum of the anti-clockwise moment. Y means what? 127 Newton. The next thing now is to find x. So to find x now, use this equation we have established here. X equals to 230 minus y. X will now be equals to 230 minus 127. So our x will be equals to 103 Newton. So the two answers we have, the two reactions, the reactions now are what? 127 Newton and 103 Newton. Thank you.